What if your Arduino could send data to the internet and you could access it from anywhere in the world? In this tutorial, you'll learn how to connect your Arduino to Wi-Fi and send real sensor data to a cloud platform. This is your first real step into building IoT systems. If you are new here, welcome. This is lesson 23 of a 24-part series called Arduino for Beginners. This is the Wi-Fi IoT module, a tool that allows microcontrollers like Arduino to connect to the internet. This component has 4 pins: DT, CR, GND, and VCC. DT stands for Data Line Transmitter, and CR means Clock Line Receiver. If you look closely at the board, you'll see a small switch. It lets you choose between different communication protocols like UART or I2C. In this tutorial, we'll use UART since it's simpler for beginners, but I encourage you to explore I2C later on. The module operates between 3.3 and 5 volts and can draw up to 240 milliamps, which is quite high for an Arduino. In this project, we will power it from the Arduino's 5-volt pin because the setup is simple. However, for more complex or long-term projects, I recommend using an external power supply. You'll also notice an RGB LED on the module. It gives you quick feedback about the connection status. Red means not connected, blue means it's trying to connect, and green means it's connected. Now that you understand the basics, let's use this module in a real project. Before we continue, a quick thank you to the sponsor of this series, GFRobot. If you are not familiar with them, GFRobot is one of the global leaders in open source hardware. They offer everything from Arduino boards to single-board computers, along with a wide range of sensors and modules. For this series, they provided the Mind Plus Arduino Coding Kit, a complete set of components for beginners to start building real projects. If you want to follow along and get the most out of this course, I recommend checking out a kit like this. You will find the link in the description. Thanks to GFRobot for supporting this series and helping make STEAM education more accessible. Now let's get back to the project. Today we are going to build a system that reads data from a sensor and sends it to the cloud. To build this project, you need Arduino Uno input-output expansion shield, DHT11 sensor, I2C LCD module, Wi-Fi IoT module, and a few jump wires. Start by attaching the input-output expansion shield to the Arduino. Then connect the DHT11 sensor to digital port 3, connect the DT pin of the Wi-Fi module to digital pin 4, connect the CR pin to digital pin 5. Then connect the I2C LCD module this way, SCL to A5 and SGA to A4. If you need additional help, follow the schematic that's appearing on your screen right now. Next, we need a cloud platform to receive the data. We'll use ThinkSpeak. Create an account and log in. Then go to Channels, My Channels, and New Channel. Give your channel a name like Arduino Weather Station. Then set Field 1 to Temperature and Field 2 to Humidity. Scroll down and click Save Channel. After that, go to the tab API Keys and copy the right API key. We use it to send data from the Arduino to your channel. Finally, go to the GitHub repository for this series, link in the description, and download the file called Cloud Weather Station. Open it in the Arduino IDE. Now let's analyze the code. At the beginning of the code, you'll find the 3 variables: SSID, password, and API key. Replace this with your Wi-Fi network name, your Wi-Fi password, and the right API key you copied earlier. In the setup function, we initialize the DHT11 sensor, the serial communication, and the I2C LCD display. We also connect to Wi-Fi and wait until the connection is established. In the loop function is where the main logic runs. Every 30 seconds, we read temperature and humidity from the sensor, display the values in the serial monitor, show them on the LCD, and send the data to ThinkSpeak using an HTTP request. You'll notice that there are also 2 helper functions: wait response and read serial. Wait response waits for confirmation from the server, and read serial reads responses from the Wi-Fi module so we know when we are connected to the internet. Once everything is ready, upload the code to your Arduino. When the system starts, you notice the LED on the Wi-Fi module changing colors. It starts red, not connected, then turns blue, connecting. Finally, it turns green, connected. After a few seconds, the LCD will display the temperature and humidity readings. Now go to your ThinkSpeak channel. You will see two graphs, one for temperature and one for humidity. These values update over time and remain stored in the cloud. Even if you turn off your Arduino, the data is still available online. This means you can access your sensor data from anywhere, which is exactly what IoT is all about. And that's it for today's project. You've just built a system that collects real-world data and sends it to the internet, something that's used in real IoT applications. If you enjoyed this lesson, consider subscribing so you won't miss the final video in the series. And before you go, check out the video on your screen right now. It will help you continue building your maker skills. Thanks for watching, and I'll see you in the next tutorial.